to do.
Okay, we'll jump into ecosystems then. First question is, what is an ecosystem? This is sometimes used as a word to describe things that are not in the natural environment, so not biological. But biologically speaking, what is an ecosystem? Thoughts? Okay, good. So we've got a physical place, an area that we're going to study or look at or describe or whatever. And we are not only interested in the living things, but also the non-living things. So what are the terms for living and non-living? All right, so we have, abiotic and biotic things which make up this ecosystem. All right, see if you and your neighbors can list out, all right, what are some abiotic factors and what are some biotic factors? Ready, go. What's up, Ellie? Kevin? Okay, abiotic factors probably easier. What are some abiotic factors of an ecosystem or elements? Okay, yeah, we've got air, the atmosphere. Anything else about the air? What's in it? Okay, so you might have the gases of the air. You might have particulate matter in there. I was thinking things like wind, okay, or water, humidity. Okay, what else falls from the air? Yeah, we got precipitation. Okay, other factors? Okay, good. Sunlight, how much sun is radiating in an area? What are some things about sunlight, if we broke that down? Okay, elevation is an abiotic factor, good. No, we can jump all over the place. But sunlight affects what in the air? Another thing. Temperature, good. All right, what else? Water. Okay, good. Bodies of water. We've got precipitation on here, like how it evaporates and or falls out of the sky. And we've got humidity as well, so that all has to do with water. Okay, what else? Okay, good. So we've got our geology, which would include, what minerals are abundant in an area, what's the bedrock, whether it's granite or limestone or volcanic rock, sedimentary, igneous, or what's the other one? I don't know. Okay, great. This is a good list. All right, we might put some of these together and use that to describe climate. All right, how these things change over a period of time in a consistent way based on location of the earth and all these other things. It's an abiotic factor. All right, what are biotic factors then? Okay, we've got the living things, right? Species of organisms.
Competition between species.
All right, we've got interactions such as competition. We went over these last time, right? What were some of the other ones? Mutualisms. Predation. Commensalism is another one. Okay? What are other biotic factors? You might have trophic dynamics, so what eats what, which is kind of a subset of predation. Minerals. Sorry, my hand. If you can't read my handwriting, just let me know. It's not the best. It's not the worst, though.
I think Dr. Gardner takes that place.
Right. Okay, what about, yeah. Okay. Stu, what were you telling me about the rabbits the other day?
Diseases?
Disease, great.
I was like,
All right, yeah, that's a biotic factor, affects living things in there, how they live in an ecosystem. Okay, good. That's a good list. So if we can describe these things together, we can get a good idea of how an ecosystem functions. There's lots of inputs, there's a lot of outputs, which just stay here. So, okay. And when we study, we can study different pieces of these. We can study them all together. That's what makes up an ecosystem. Yeah.
Are viruses considered abiotic or biotic?
That's a good question. Well, they do cause disease in biotic things, but they aren't necessarily living. Yeah. I would say they're biotic, though, because they're... in this sense. All right, we good? This isn't necessarily an exhaustive list either. We could probably think of some more things that could fit in both areas. What about types of ecosystems? How are they generally described? Okay, they're generally described by a major feature of that ecosystem. All right, so you may have freshwater ecosystems. All right, these are looking at rivers and lakes. Or you could have marine ecosystems. Or you could have forest ecosystems. Or you could have urban ecosystems, those associated with humans and cities, right? Sometimes you might even get into the microscopic and talk about the microscopic ecosystem of bacteria and small unicellular organisms and how they interact with algae, so on and so forth, okay? All right, so those are just some of the examples, but there's lots of different types of ecosystems. And they all can depend on the scale or the different abiotic or biotic factors that you're interested in.
What's the last one you wrote down?
Urban. All right, any other thoughts, comments, questions on ecosystems? Got a good idea of what they are? Okay, let's talk about ways to discuss some of the factors in an ecosystem. A microclimate is, or a microhabitat is what it also might be called. Is a feature that creates a different set of measurable factors in an area. Okay, so I'll give you an example, then I want you to think of other ones. So I drew a mountain here. All right, there are different places on this mountain that are going to have different, temperatures or different humidity or different water availability, depending on the features around them. So for one example, I'm going to say I've got this tree here. And this tree is going to create shade, and that's going to create a spot that is cooler than an open spot. And so that's going to be one type of microclimate or microhabitat. So I want you and your neighbors to think of, well, what are some different things on this mountain that might create then those different conditions? And then we'll talk about them together. Ready, go. You can draw them in. Water. What type of water?
Big boulders, like that boulder, it's a nice boulder. Is there a small bottom? What did you just say?
Submit it to nature.
We can do like a river, right? Because
Yeah.
the mountains have rivers in them.
Yeah. A little river, a little stream. Something.
What's the singular of bacteria?
Bacterium. Yeah. Yeah. They just usually aren't found alone, so don't use that term here. Okay, what are some things you drew on your mountain?
A river.
Okay, good. There's lots of bodies of water you might draw on here. Maybe there's a little spring where water's coming out of the mountain. It creates a little stream. Feeds into a river. You might have a little lake or a pond or other things in there too. All right, great. So this is creating differences in water and moisture on the soil next to it. It's also got this habitat in itself, fresh water, which is coming down the mountain. So that's great. All right, what else?
Snow at the top of
Okay, you've got snow at the top of yours. All right, so there's really cold, icy, snowy parts. This also can help capture moisture that will be released throughout the warmer months as it melts, and also might contribute to then our streams as well. Sorry, somebody else said something in the back?
I said a cave.
A cave, okay, good. We've got a cave here. Caves are interesting. If you go in a cave, the temperature should be about the same year-round, right? So it's usually the average temperature for that habitat. So you'll have a much more stable temperature in here. Caves will often have water in them, especially in these parts. So yeah, lots of environmental conditions are unique to caves. Kate, you had one?
Yeah, I just had rocks,
Okay, good.
especially with different elevation. Like if you have 14er, then there's no trees, and it completely, like you're in forest, and all of a sudden you're just in like rock landscape.
Okay, good. Yeah, so rocks make it hard for some things to grow on them, and so that exposes them to sunlight. What living things might you find on these exposed rocks? Lizard, yeah, those that are trying to get warmer, right? So snakes and lizards might warm themselves on these exposed rocks as the sun shines. Okay, great. What else?
the right side, super windy.
You got wind on one side. Yeah, right. And our forests can also affect then the wind. If there's lots of trees, it generally tempers how much wind is below the canopy. Okay, great. I drew the sun up here. Okay, if this is a south-facing mountain, south-facing slope, and this is the north side, all right, which side is going to be warmer, hotter, drier? Yeah, generally the one that gets more sun on the south side of it. So you'll see, especially in arid environments, like in Southern California or Utah, the south-facing part of the mountain will be dry, have not a lot of vegetation. You go to the north side where it's cooler, where there's less evaporation taking place, you'll generally find more vegetation, bigger plants, more things living there, more moisture. Okay, anything else you drew on here?
Grass.
Okay, yeah, vegetation will definitely affect, ooh, that's not green. Come on. Grass, as opposed again to like exposed areas, will help to capture moisture, create soil stability, prevent erosion. There's also living things that prefer to live in the grassy areas, such as rodents and perhaps snakes and other things that are going to eat the rodents. Okay, good. Now, you don't have to, this is our theoretical mountain. If you really want to look and find and see different microhabitats, go on a hike up a mountain. And you'll notice as you perhaps go up in elevation, what happens? What do you see? Yeah, the temperature drops as you go up in elevation, and the vegetation changes as well. So the higher or closer you get to these icy mountaintops, the smaller the vegetation will get to as well, because there's less soil, it's colder, less potential for growth. Now, these mountains don't have snowy, icy tops and glaciers and stuff, but out west, where they're a little bit higher, you'll see more of that. But you can still see vegetation changes in these mountains that are still a couple thousand feet in elevation change. And as you go up, you'll see different vegetation. So elevation also creates then differences in microclimates. Okay, one other thing. Let's say this is an east and west side slope, all right? So the sun is going to actually cover, as it goes up and down over the horizon, it will have 6 hours on the east side and 6 hours on the west side. Which side do you think will be drier and hotter, and which side do you think will be cooler and more moist, east or west?
I think west is.
Here, discuss with your neighbor, see if you can think. Which one's going to be hotter, which one's going to be cooler, east or west? Right, yeah, the sun rises in the east and sets in the west. All right, who says east is going to be hotter? Okay, who thinks the west is going to be hotter? Okay, why do you think the west is going to be hotter?
Because the hottest part of the day is like around 2 p.m.
That's good, yeah. So even though the east side gets the sun first, it's getting the sun while it's cool out, while it's just dark. So the east side is going to be cooler, whereas the west side, it's going to start its sunshine in the middle of the day when it's already warmer. And so the west side of the mountain will be drier and hotter. East side will be cooler and wetter. So if I'm looking for salamanders need moisture, they need cool temperatures, and I'm looking for them in the middle of the summer. Which side should I go to? East side, right. And so a lot of these mountains do have this kind of east-west configuration, and I have actually gone out looking for salamanders. The east side of the mountain is going to have more than the west. And if it's north-south facing, then the north side is going to have more than the south. Okay, let's move on. Why do we care about healthy ecosystems? All right, first off, what is a healthy ecosystem? All right, it's going to be an ecosystem that those natural processes of nutrient recycling, which allow the living things to flourish in that area, are going to be intact. Right? Unhealthy ecosystems have something disturbed where those processes are thrown off and the living things are having a much harder time surviving. So this is for you and your neighbors, then we'll talk about it together. Why do we care about healthy ecosystems? Discuss. Maybe you don't care. Okay, thoughts? Yeah, Caleb.
We care about healthy ecosystems because those healthy ecosystems help other ecosystems become healthy as well.
Okay, so we have ecosystems aren't generally isolated by themselves. We are connected to other ecosystems. So we have, I'm going to use a different color. Ecosystems are connected. All right, other thoughts?
A healthy ecosystem is sustainable because it's sustaining itself. And so when we disturb that, then we kind of take away that sustainability. And we want to have the earth being sustainable for future generations.
Okay, all right. So a healthy ecosystem is one that, in theory, can perpetuate itself. And why do we care about that? Yeah, Gavin.
If all of our ecosystems just like crumble and die, then we probably won't be able to sustain ourselves, and we'll probably all die after that.
Right, because what's our connection to the ecosystem? Right, yeah, so we get ecosystem goods and services, right? If the ecosystem collapses, where are we going to get our goods and services? What are some goods and services we get from the ecosystem? Okay? Yeah, wood. All right? If you cut down the trees and you don't allow for them to regrow in a sustainable manner, you're going to run out of wood. Okay? What's that? All right. Anything else? Food, right? We've, kind of destroyed ecosystems to create food crops, but we still have to maintain the health of the soil and the water in order to supply our food with the things it needs to grow. So, very invested in the health of those ecosystems for those reasons. All right, what else? Okay, yeah, water is a big good. Clean water that we like to drink. We don't want it to be degraded or polluted or brown, have lead in it, anything like that. So our health, a healthy ecosystem means healthy people, right? All right, any other reasons? All right, what if this wasn't true? What if we figured out we can destroy the ecosystems, but we'll, technologicalize our way out of any problems?
I think beauty is worth sustaining.
Okay. So healthy ecosystems are beautiful. We have an aesthetic value to a healthy ecosystem. But we can just go into the metaverse and get all that, right? What's that? Yeah, you just put on your VR headset and or get on your Peloton and I'm running through the forest, right? Yeah. Right. I don't think you can quite capture the aesthetics or the experience of a healthy ecosystem through a VR. Not yet. Maybe someday. Okay. Anything else? Okay, good. That's another service that an ecosystem provides to us. There's this idea of intrinsic value. All right, healthy ecosystems are valuable by their existence And us destroying them is a moral wrong. Right? Just because we can and are able and profit from destroying ecosystems doesn't mean we should. We should be thoughtful and think about, well, what does this mean not only for us, future generations? What does this mean for our planet? There's value in having healthy ecosystems. This one's a little more philosophical than these, which are more practical, but
Is that value or value?
value, sorry. There you go. I can do better. All right, well, I want to skip ahead to something called the trap. Move back to, let's see, how much time we have? We only have 10 minutes. All right, the assignment for today is we're going to watch this video on island foxes, and what I want you to look for are abiotic and biotic factors that were important to the recovery of this island fox. Okay, so we have these organizations which manage the land for us, and we have these designations of different land, and you are allowed specific things, allowed to do specific things, and then you're not allowed to do other things. You're restricted in other ways. So what I want you guys to do for the last 2 minutes is pick one of these, look up what is the organization that manages that type of designation, and then what are you allowed to do and what are you not allowed to do in these areas. Okay, so you and your neighbors pick one and do some research on it. All right, commons. Has anyone heard of this before? It's an economic concept. Which the basics of it are unregulated ecosystem goods and services lead to their destruction.
Can you zoom in a little bit?
I can zoom in a lot. I'm just kidding. Yeah. Unregulated ecosystem goods and services lead to their destruction. And this is a bit of an allegorical story to relate this. Okay, so the commons so this is going back to kind of, if you can think of this as kind of like medieval lifestyle, where you have the lord of the pastures, right, who decides which serfs or which peasants get to use different areas, okay? And so you have peasant one over here, and he's going to have his sheep. That's a sheep, okay? And that's his area, okay? Peasant one is given that spot over there. See if I can duplicate this. All right, peasant 2 is allowed to go over here. It's called the short-necked, the no-faced sheep. It's a certain breed.
It's French.
Yeah. If you're not into shepherding like I am, you probably have never heard of it. Okay, so we have all of these peasants and their land and their sheep, all right, and they're allowed these specific areas. And they are invested in their areas and making sure that they are grazed appropriately, they aren't overgrazed, they take care of the land, and so they're creating sustainable plots here. Okay, if the Lord says, the Lord of all the land says, all right, well, I have this commons area. And the commons is open to anyone. You can go in and you can use this as much as you want, and it's free. All right? What are all of these shepherds, peasants, going to do with their sheep? Yeah, they're going to go to the commons. They're like, all right, well, I'm going to take my sheep and go into the commons area. And what are they going to, then they're going to try and exploit that as much as possible because it's free. It's not their private land. They don't care if it's degraded. And it's going to increase their shepherd flock because it's not going to pull from the resources that they do care about. Well, what's going to happen to the commons area? Yeah, it's going to get overgrazed. It's going to not be taken care of. All of the vegetation on there is going to die, and it's going to be left an uninhabitable place where none of these sheep can live anymore. And eventually the shepherds can go back to their little area and, they'll sell off their extra sheep and they'll be fine. But the commons will no longer be sustainable. It'll be destroyed and probably won't recover for a very long time. All right. How would you prevent the commons from being destroyed? Yeah.
You could establish some regulations on how people act while they're there.
Yeah, right. So the Lord said, yeah, you can use this, but hey, you need to respect that they're going to have a turn, and they're going to have a turn, and they're going to have a turn. Maybe set up a system. Or maybe even have a person appointed to be in charge of this area to make sure that it's taken care of. Whatever it is, as long as there's some regulation there, it generally won't be depleted. But when it's unregulated, this seems to happen. And we do have some examples of this happening in some things like fisheries. So the cod fishery, the Atlantic cod fishery used to be like the most productive fishery in the world. But it was out in ocean that was unregulated, and as fisher people advanced more in technology and were able to catch more and more of the fish, and more fleets from different parts of the world came to this area, they overfished the cod to the point where now it's collapsed. And the cod, there's no more cod, well, there's very few cod, and it takes them a very long time to recover. They don't reproduce till very late in their life. And so all of these people that were relying on these cod fisheries are now out of a job and have to find a different place. So regulation, the point of this is we need some sort of regulation. We need something in place in areas that seem to be free and open, otherwise they will be degraded.